Hello everyone, we are Group 5, the Mouse Security Robot Group, and here is our video of our second week of work, the Deliverable 2 video. So, our schedule status. First, we expected to work 56 and a half hours. We spent 42, almost 43 hours on work. We are currently 13 and 40 minutes delayed, but to compensate that, we are 15 and a half hours in advance. These hours come from tasks from weeks 3 and 4. So a little rewind of our last week. Last week we had 3 delayed tasks. One of them still delayed, the buy components. Actually, there's only one component missing, that's the camera. But tomorrow, Wednesday, we'll talk to Professor Rosato that has a good idea, a good experience about the camera and the connection with the Raspberry, the night vision detail. So we hope that tomorrow we can decide which camera we will buy. The Raspberry Pi internet connection test is done, and the last task that was delayed from last week was the encoder's placement determination that is also done. So the major advances we made on our project this week. First one is on the project structure. We built the structure of the components, the case. So here you can take a look. This case on top is for the camera. This one below is for the siren, and this big one is for the other components. Here you can take a look for another view. You can see the height of our board. Below we have the motors, the battery, and the motor modules. The height of the board from the to the ground is approximately 20 centimeters. Here we have a top vision without the board, so the motor modules, the battery, the motors of and the wheels. From the project structure, this is it. We also made the circuit design. So passing quickly, we have here the microprocessor, the ESP32, that is connected to the horn. A simple connection, just the power and the ground. It is also connected to the encoders and the motor modules. These BTS are the motor modules. That is connected to the motor. These 12 volts come from the battery, this and the other motor. This is supplying the motors. And all the 5-volt supplies come from the ESP32. This VI in are the same is the same as all the other 5 volts here in the diagram. So the ESP32 is also connected to the compass module and to the Raspberry Pi. We're gonna do a wire connection. And Raspberry controls the servo motor that makes the camera rotation. We also did the database design, the ERD. So we also have here tables for optional tasks. So username and password or sensor readings are optional in our schedule. We decided to put it here, but it's not sure that we'll implement it, that we'll develop it. But the main part here are the routes. So here's the link between the route and the user. Each route has several route steps, and each step is between two Aruco markers. Will not necessarily have one step between each Aruco marker. We can have multiple steps between them, between consecutive Aruco markers. We also have the route execution. So each time the robot goes by the route, it will start a route execution that will be linked to the alarm triggering and the camera triggering. So each time the camera detects a movement, it will start in the specific route execution that have a moment of start and a moment of end. And basically that's it for the database. So in the current week, we have 4 tasks that are stuck. They count as delayed, but we decided to put them as stuck to organize better. Why are they stuck? Because we need the camera to finish them. So the task delayed is the by component is the by camera task. And once we did that, we will be able to finish these tasks here. So we have 5 tasks delayed. In progress, we have one that will finish till Thursday, the encoder installation plus unit test. All the others are done, and we decided to advance 3 tasks to compensate the delayed tasks. Right now, we are, if you compare the delayed and the advanced hours, we are actually on advance. And this is it. Thank you for your attention. Goodbye.